Hi folks, in this video I will be showing you how to graph a quadratic function using a few principles starting with the vertex, axis of symmetry, x-intercepts if there are any, and the y-intercept. So let's go ahead and begin. In my opinion, the vertex is the most important point of a parabola, and the reason is because it's a switch point. It dictates at what place the parabola changes from increasing to decreasing or decreasing to increasing. So those points are crucial. And it also is important because the vertex indicates where the axis of symmetry divides the parabola into two equal parts. So with that in mind, let's go ahead and get the vertex first. Now there's a small formula to do this, and the formula is this. It is x is equal to negative b all over 2a. Now, that formula is just a piece of a bigger formula called the quadratic formula. So we need to have our a and b values, which I can get directly from the function. So my a value, which would be right there, is a 1. My b value, which is right there, is a negative 2. Okay, the negative does matter. So replacing those values in here, what I get is negative 2 over 2 times 1. Now, this would be 2 over 2, which is just a 1. Now, that's not the end, but it does give me the x value of the vertex, which is important because I already know my graph will be out 1 and then up or down somewhere, or either directly on the x-axis. So to figure out where that y value would be, I then take this 1, I go back to the function, and I substitute it into my x's. So this would now be the part where I get y, okay? And to do that, you just replace. So f of 1 is equal to 1 squared minus 2 times 1 minus 3. Then you just crunch the numbers together. So this would be 1 minus 2 minus 3. And if you put everything together at once, 1 minus 2 is negative 1. Then negative 1 minus 3 is negative 4. And just like that, we have our y value. So putting it all together, the vertex would be located at the following location, 1, comma, negative 4. Okay? Now, I need to go ahead and plot this point because there is a second thing I can do that is almost absolutely free and based on this answer right here, and that is the axis of symmetry. So we'll get to that in just a moment. But first, the vertex is at 1, negative 4. So 1, negative 4, right there. Vertex, capital V, important point, capital letter. Okay. Now, being that this is way down here already, and the fact that my a is a positive value, I know that this parabola is going to be like a smile. Okay. So it's going to go down, swing back up again. My axis of symmetry is always given by an equation that starts with x is equal to, and then some value here. Now the value that goes there is simply the same x number belonging to the vertex. So in this case, it would be a 1. And the reason for that is because, like I said earlier, the axis of symmetry cuts a parabola into two equal parts. When it does so, it will invariably cut through the vertex because the vertex is at the very center of that parabola. Again, it's a switch point. And this happens at the middle. So drawing this in would look something like this. And as you can see, it cuts right through it. Now, I like to put arrows at the end because it is technically a line, though it is an imaginary line, it is nevertheless a line. So the equation for this would be, and I'll do it like this actually. I'll write it this way. So the equation for this would be x is equal to 1. Okay, that's the equation of that line. Now, to get the rest, so the y-intercept is always your constant. It's at the very, very end. So in this case, it's negative 3. So my y-intercept would be 0, negative 3. And that's a free point. So that goes right there. And because my axis of symmetry acts like a mirror, every point on one side gets reflected on the other side. So it's like I get 2 for 1. It's a good deal. So if I have a point here, then I have a reflection of this point on the opposite side, the same distance from that axis, there. Okay? 2 for the price of 1. What takes a little more effort and work is figuring out the location of the x-intercepts and whether or not you even have x-intercepts. There's a quick trick to doing this. It's called using the discriminant. The discriminant uses the part under the radical of the quadratic formula, which is a b squared minus 4ac. It uses this without the radical to determine whether you're going to have 2 x-intercepts, 1 x-intercept, or none at all. And the trick to doing this is just taking those a, b, and c numbers and plugging them right in. So going back to our function, our a is 1, our b is negative 2, and our c is a negative 3. So c is negative 3. So what I do is I take those numbers and I come over here and I substitute them into the discriminant. And the only purpose of doing this is to see whether I'm going to get intercepts at all, okay? How many you're going to get that's something you can figure out by just factoring or the quadratic formula. But it's good to know whether or not you should even take the trouble and time to do that. So I'm going to use this to see if I will even have x-intercepts, even though I can tell that I will, okay? Because this is going to go up. So plugging this in, I would get b squared would be negative 2 squared minus 4 times 1 times negative 3. And that would be 4 plus 12. And this is indeed, that's a 16. And all that 16 means is because it's bigger than 0, 16 is bigger than 0, all that means is that I am indeed going to have some x-intercepts. So I better figure out where exactly they will be. So yes, I will have x-intercepts. So here's where they are. Where? Here's how we figure this out. So there are 2 ways to figure this out. One is to factor the function and then solve it. The other way is to use something called the quadratic formula. There is a third way called completing the square, which I will not get into in this video. So my focus will be actually doing both factoring and solving and the quadratic formula. You can decide which one you like. So the function again is x squared minus 2x minus 3. So I'll just write it over here again. F of x equals x squared minus 2x minus 3. If I were to factor this out, factoring would look like this. So I create 2 binomials. I change my f of x into a 0. And the reason I do that is because, again, I'm looking for x-intercepts. And x-intercepts are points that lie on the x-axis. And any point that lies on the x-axis will have a y value of 0. So this f of x becomes a 0 for that reason. Okay, so then to factor this out mentally, you just look at your x squared and ask yourself, what times what is x squared? So x times x is x squared. Then what are 2 factors of negative 3 that also add or subtract to make negative 2? Well, it turns out that not many things multiply to make a 3 in the first place. So I know I'm going to have a 1. I know I'm going to have a 3. I need to have a negative product. So one of these numbers will have to be negative. And I know that when I subtract them, I need to get a negative 2. So that means that this 3 will need to be negative, and the 1 will have to be positive. Okay, and then I test it out. So 1 times negative 3 is negative 3. 1 minus 3 is negative 2. It's factored. Then what you do is you want to break it and solve it. So breaking and solving simply means this. You assign a mini function to this, a mini equation out of this, and it looks like this. So the purpose of doing that is to figure out what value of x would turn everything on this side into a 0. And there are 2 possibilities because we have 2 x's here. So the first possibility is if x is a -1, then this binomial would become a 0, which would make everything here a 0 as well. The second possibility is a 3, because if x were a 3, then that would mean this binomial would become a 0, 3 minus 3, and that would multiply with this and make everything into a 0 as well. So those are my x-intercepts. My x-intercepts then lie at the following places. This would be at -1, 0. This would be at 3, 0. And I can go ahead and put those points directly on my graph. So on my coordinate plane, rather. So this would be -1, 0 up here, and then 3, 0 right over there. Now, at this point, I have enough to make a good parabola, and I will do so. But first, I did tell you that I would show you another way to get these x-intercepts, and that would be using the quadratic formula. And I want to keep my word on that. So quadratic formula would go like this if you were to use this method. So it would be x is equal to -b plus minus square root b squared minus 4ac all over 2a. So I need my a, b, and c numbers. So plugging them in, I would get x equals -2 plus minus square root -2 squared minus 4 times 1 times -3 all over 2a, which is 2 times 1. Now, at this point, I'm just breaking this thing down until I have what I need. So this is 2 plus minus square root. That would be 4 plus 12 over 2. 2 plus minus, that would be 16 over 2. Now, if you have a radical that is perfect, that's great. If you can reduce it, or simplify it, go ahead and do so. Always do so. So square root of 16 is 4. And so this is where I am. Now, at this point, I need to split this because I have to separate this plus from the minus sign. Okay, as you saw from factoring and solving, I do end up with 2 x-intercepts. And even if I don't, and I end up with just 1, I would still need to consider, that these 2 need to be separated. Most likely, though, it's only when you're going to have 2 x-intercepts. So the plus would go here, for example. The minus would go there. You're splitting these together, or from each other. The first one would be 2 plus 4 over 2. The second, 2 minus 4 over 2. And then you simplify. So this would be 6 divided by 2, which is 3. And this would be -2 over 2, which is -2. And as you can see, they're the exact, -1. So they are the exact same answers I got earlier over here by factoring and solving. So whether you use one method or the other, you should get the same answers either way. So number 5, additional points, I don't need them. If I did, I would have to make a function table, fill it out, and get a few additional points to make my parabola possible. But I don't need them because everything I got from my work earlier makes this possible to draw, and draw pretty well. So what it would look like as a finished product would be something like this. Again, you want to make sure that your parabola does not look like a letter V. It shouldn't have a sharp angle in there anywhere. It should have a nice curve. So I hope this video helped you out. Please stop by, leave a comment, and as always, thanks for watching. Bye-bye.